Determine if each function is even, odd, or neither. Referring to the notes below, a function is even if f of x equals f of negative x. In addition, the graph has symmetry about the y-axis. A function is odd if the opposite of f of x equals f of negative x. In addition, the graph has rotational symmetry about the origin. We'll first determine whether the given functions are even, odd, or neither using the function rule, and then we'll verify the results graphically. Number 1, we have f of x equals 2x cubed plus 5x. Next, we'll determine f of negative x, which is 2 times the cube of negative x plus 5 times negative x. Simplifying, we have negative 2x cubed minus 5x. Notice f of x does not equal f of negative x. This indicates f of x is not even. And now we'll determine the opposite of f of x, which is the opposite of the quantity 2x cubed plus 5x, which equals negative 2x cubed minus 5x. Notice f of negative x equals the opposite of f of x, which indicates f of x is odd. Number 2, we have g of x equals x squared plus 4. Next, we determine g of negative x, which equals the square of negative x plus 4. Simplifying, we have g of negative x equals x squared plus 4. Notice g of x equals g of negative x, which indicates g of x is even. The only function that can be both odd and even is f of x equals 0, and therefore we can stop and classify g of x as even. Number 3, we have h of x equals the square of x minus 2. Next, determine h of negative x, which equals the square of negative x minus 2, which does not equal h of x. And now determine the opposite of h of x, which equals the opposite of the square of x minus 2. H of x does not equal h of negative x, and h of negative x does not equal the opposite of h of x, and therefore we answer neither. Number 4, we have j of x equals 1 divided by x plus 3. J of negative x equals 1 divided by negative x plus 3, which equals negative 1 divided by x plus 3. J of x does not equal j of negative x. J of x is not even. Now we determine the opposite of j of x, which is the opposite of 1 divided by x plus 3, which is negative 1 divided by x minus 3. Notice j of negative x does not equal the opposite of j of x. J of x is not odd, j of x is not even. We enter neither. Number 5, we have k of x equals the absolute value of x minus 1. K of negative x equals the absolute value of negative x minus 1. The absolute value of negative x does equal the absolute value of x, giving us the absolute value of x minus 1. Notice k of x equals k of negative x. We can stop. K of x is even. And the last function is m of x equals 1 divided by x plus 2x. Next, determine m of negative x, which is 1 divided by negative x plus 2 times negative x. Simplifying, we have negative 1 divided by x minus 2x. M of x does not equal m of negative x. M of x is not even. And now we determine the opposite of m of x, which is the opposite of 1 divided by x plus 2x, which is equal to negative 1 divided by x minus 2x. M of negative x equals the opposite of m of x. M of x is odd. And now let's verify this graphically. Notice f of x and m of x are odd, g of x and k of x are even, h of x and j of x are neither. Let's begin by looking at just f of x as well as m of x. Actually, let's just look at f of x first. Notice this graph does have rotational symmetry about the origin, because if we turn this anything less than one turn about the origin and it looks exactly the same, we have rotational symmetry about the origin. If we rotate this 180 degrees in either direction, the graph would look exactly the same. We have rotational symmetry about the origin. Verifying the function is odd, and the same is true for m of x. If we rotate this about the origin 180 degrees, the graph would look exactly the same. And now let's take a look at the two even functions, which are g of x and k of x. Notice both of these graphs have symmetry about the y-axis. If we folded these two graphs about the y-axis, it would match up perfectly with the other half. And then both h of x and j of x, let's look at just h of x. Notice h of x does not have symmetry about the y-axis or rotational symmetry about the origin. However, if the graph was shifted left 2 units, it would be an even function because it would have symmetry about the y-axis. And then finally for j of x, again, j of x does not have rotational symmetry about the origin or about the y-axis. However, if the graph was shifted down 3 units, it would have rotational symmetry and be an odd function. I hope you found this helpful.